Hi, okay, so in question 6 of the same sheet, the exercises 1C vectors, they give you a diagram that looks something like this. So there's 400, there's a few ropes connected to the support, so this is not a weight that's hanging down, it's like a support. And they tell you that these cables are all in equilibrium, the forces are all in equilibrium, so you have upwards 400 newtons force, this unknown force x newtons going in that direction, and this one 300 newtons going in that direction, and they tell you that these are all in equilibrium and your job is to find x. And the way that I did this question, it's funny because at the beginning it looks a bit weird because they don't give you the angle or anything, so how are you supposed to know what happens with the angles? And so I'll just do it and you'll see why. So the best thing with these questions is to just start thinking and writing things down and see what happens, and you might find out then why they don't have to give you the angle. So how do we do these questions when you have different forces going in different directions? We have to resolve. It's called resolving in different directions. So the two directions here that make sense, you always resolve at right angles, so that each resolution you're doing is at independent from each other and they don't affect each other. So here we have horizontal direction like this, and we have a vertical direction. So I'm gonna resolve first horizontally in this direction. So this force here, this one is easy, we don't need to split it, and this one we don't need to split it because this one is completely along this angle horizontal and this one completely vertical. So the only force that needs splitting is the x here force. So how do we split that? Well, we just need to make a triangle. I'm going to use a different color. We just need to make a triangle like we always do with the two directions. Okay, one of them, one of the components of this x is gonna be in this direction, right? Because it's going in that direction, so some of that force is gonna be going in this direction, and the other component is gonna be going down, right? Because this diagonal is a combination of those two movements. So the x has those two components. And what they're telling us by saying it's in equilibrium is that this down component of the x is sufficient to cancel out this 400 newtons, because this 400 is going up, so this down part of the x has to be cancelling out with those 400. And they're also telling us that this left component here must be cancelling out with the 300 newton force going down to the right, so that the x component of, sorry, the horizontal component of this x going left has to be the same as 300. So if we just call this angle theta, which is the one that I was hoping they'd give us, then my formulas are, as always, for the opposite and the adjacent. They're always sine. So the hypotenuse, x times sine, would be this one, and x times cos would be the adjacent. So resolving in the horizontal direction, first we have x, the whole hypotenuse, times the cos of theta is the one that's along here going left. So we know that x times cos theta that goes left is equal to 300. The magnitude must be equal to 300, right? Yeah, they both must be equal. One of them points left and the other one points right. And so that's it for the horizontal. And for the vertical, we have this one here, this component there, and that's going to be the sine theta component of x, because it's the opposite side of the triangle. So in that one you would have x sine theta is equal to 400 in this case instead of 300. Right? So these are the two equations that I have. I've used all of the information that I have in the question, and these are the two equations that I have. I don't know what theta is, so I can't use theta here to find x or find x using this one. I can't do it. But what I can look at, what I can do is to combine these two equations together to get something useful. So whenever you have something with a sine and something with a cos, I recommend that you use this. You can also do substitution, but this is easier. Just use the fact that sine theta over cos theta is equal to tan theta. So then you can have a simplified version. So in other words, if I call this equation 1 and this equation 2, if I divide equation 2 divided by equation 1, what I get is a sine divided by a cos, so I can then simplify that. So what does the equation 2 look like? X sine theta is the left hand side, and if I divide it by equation 1, which is x cos theta, then on the right I'm going to have 400 for the equation 2 first, and then divided by 300. So here the x divided by the x are this, they go away, they cancel, and I'm left with sine theta over cos theta, which is just tan theta. So that simplifies everything, and then 400 divided by 300, I can cancel the hundreds, and that's the same thing as 4 divided by 3. And so now I can get my theta from here. Theta is equal to the inverse tan of 4 divided by 3. And that comes out to be 53.13 degrees, something like that. 53.13 blah 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 degrees. So now that I know what theta is, I can go to either of these two equations and get my x. So if x cos theta, which this was equation 1, if x cos theta is equal to 300, then if I want to find x, I just need to do 300 divided by cos of theta, where theta is 53.13 blah blah blah. Make sure I use the full number, and so for x I get 500 newtons, pretty much exactly. So now I know the angle and I know the force. Okay, that's one method of doing it. There's another method a little bit quicker of doing it, which takes a bit more of insight, but this was the general method that you need to know generally. It's very, very useful just to resolve in one direction and in the other. But also you can look at this triangle and say, wait a moment, basically what we're saying is that these three triangles, these three vectors have to add up to 0. Right, so they need to have a resultant of 0, and within in any triangle, if you add one vector in this direction, then one vector in that direction, then another one in that one, if you add these three triangles, you get 0, because if you start the three vectors, because if you start from here, then that way, and this way, then your overall resultant vector is just going from here. If you go from the tail of the first vector to the point of the last vector, you haven't moved at all, so this always adds up to 0. So whenever you have a triangle of vectors like that, the resultant is 0 if they're all going in the same direction, circulating like this. So here you can just say, okay, so I need to find the third side of a triangle, where one side is this one, and it's 300, which is this one here. The other one is the x, which is diagonal, which goes across here. This one is x, and this one vertical here is the same one as this one vertical here. You can put it here and then put the 300 there, or just put it on this side over here, and that's the 400, because it's just about the geometry. They need to add up. So the question is then, what's this? And then you can just choose Pythagoras. 300 squared plus 400 squared is equal to that. Comes out to be 500 newtons also. And this angle you can get it in the same way, by opposite tan of theta is opposite divided by adjacent, 4/3. So you end up doing exactly the same thing as we've done here, but a little bit quicker without having to resolve in one direction and then the other. You just do it directly by geometry. Okay, hopefully that helps. I'll see you in the next